We are on the module Pricing and Valuation of Forward Contracts, and for an underlying with varying maturities. Two LOSs to get through. First one, explain how the value and price of a forward contract are determined at initiation, during the life of the contract, and at expiration. We've already seen how we arrive at the price of a forward at initiation, so we'll just do a quick review here. The value of a forward contract at initiation is set equal to 0. No money changes hands for a forward contract. The value at any time sub t for capital T expiration changes as time passes, as interest rates change, and as the underlying price changes. We've already seen these. The calculation of the forward price is the spot price carried at whatever interest rate we have if we're compounding, or if it's continuously compounded, we'll use Euler's constant. If there are costs and income, we take the spot price, we add the present value of the costs, we subtract the present value of the income, and then we'll compound it to the end of the term. Or if we're using continuous compounding, it's R minus I. I is a rate, a continuously compounded rate at which income is earned. C is the continuously compounded rate at which costs are incurred. And our payoff at time t is simply whatever the spot price is minus whatever the contract price is. That is for a long position. If it was a short position, we would just write it the other way around, minus st, because if this is the payoff for a long position, the short position just has a negative sign in front of it. So if you bring the negative signs through, you'll end up with this. At any given point in time, if we were here, little t periods of time have passed. That means there's capital T minus little t periods left. We're over here. The value of the contract at this point in time is the current spot price. And remember, we have to compare money at the same point on the timeline. So if you didn't know anything about these formulas, what would you do? We need the value here. We have one sum of money that's here, one sum of money that's over there. We would have to discount this back to this period of time and then take the difference. So it's ST minus the contract price discounted back to the period of time where ST is. Another way you could do it is say, well, let me take ST and calculate what a new forward price would be based on where we are at this point in time. You can then take the difference of the two forward prices and then discount the forward price back. But why bring something forward just to bring it back? Why not just bring this one back and take the difference? All right, let's look at it with some income in here. And we want to value the contract at this point in time. We can forget about everything that's happened back here, by the way. If we're valuing at this point in time, we have to compare dollars all at the same point in time. Well, we have a price, we have income, and we have a futures price. You got to bring them all together. So you have to discount back the income and subtract the income. There's ST minus the present value of the income. Then you have to discount back the forward price and then take the difference. So ST, the current stock price, minus the present value of any future income. We can ignore everything back here. Only what is forward matters. And then there's the forward price, the original contract price, discounted back by whatever the interest rate is over this period of time, not the original period of time. It may be the same interest rate. Typically they are not. So you have to make sure you're discounting it back by the appropriate interest rate, and the interest rate to discount it back is the rate that applies for this period of time only. Let me get rid of some of that stuff on the timeline because it's a little bit messy there so that we can see what we have. There we go. Back it out a little bit more. And then the capital T minus T. This is capital T. This is little t. So T minus T is just this period of time. So let's just look at how gains and losses change as the underlying moves. Here is the spot price, and we'll assume that the underlying has no costs or no income, just to make it really simple. We know that the forward price is the spot price carried by the interest rate for that period of time. So it is an upward slope because the interest rate adds value to the underlying as you move forward. And then as the underlying price moves above this line, you move into gains or losses. So everything under the line would represent a loss to the forward contract. Everything above the line would represent a gain to the forward contract. So if we calculated the value of the forward contract at this point in time, we would have gains. If we calculated the forward contract at this point in time, we would have losses. So the value of a forward contract can change for a number of reasons. Have a look at this. Let's say that we are at this price and time passes, but the underlying price does not change. The underlying price does this. Does not change. Well, look at this. You'll always be in losses if the underlying price does not change, because the passage of time, unless you have a underlying that is rising at that percentage, rising at least 2% over time, just the passage of time will take away value, because we will lose on the interest carrying cost of that. If interest rates change, because remember, if we're at this point in time, we're discounting back this at a particular interest rate. Well, if interest rates are different, we may have a gain because of an interest rate or a loss. Let's see if we can separate the effect of those. Let's just do a change in rates. We have a spot price of $50, a rate of 2%, and our contract term is 6 months. If we calculate a forward price with these variables, we will get to $50.50. Now let's say that once we set up the contract, we head back to the office and we notice that rates have gone up 20 basis points. What's the value of the contract now that rates have changed? Well, we haven't left day zero. We're still at day zero, so the underlying is still $50. We've signed a contract. That price is the price. The contract price never, ever changes. So it's still 50-50, but now we're discounting it back at 1.022 as opposed to 1.02. Because interest rates have gone up 20 basis points, the new discount rate is 2.2% for 6 months. The present value of the forward price is $49.95. We just made a nickel because rates increased. So as rates are going up, discounting, we're discounting at a larger discount rate, the present value will get lower and lower, and we will have made money just with the changing rates. Now, if rates going up are good, there's a smiley face, rates going down must be bad. What about the passage of time? Let 2 months go by, and we'll keep everything the same. We'll assume the same interest rate. We'll assume the same spot price, that the price of the underlying hasn't changed and interest rates haven't changed. Just 2 months have gone by. Well, now we're only discounting back that fixed forward contract price. Remember, this does not change. We're only discounted back for 4 of the 12 months, not 6 of the 12 months. That is 50.17. It stayed at 50. Notice that we are now down 17 cents per underlying unit on this contract just with the passage of time, because this has to grow at a rate of 2% over that period of time just to break even. We need the interest rate growth in the underlying just to break even. Let's change a whole bunch of things now. Let's say 2 months have gone by, which means we had a 6-month contract. 2 months have gone by, which means there's 4 months to expiration. Since we're dealing with interbank rates, we're on a 360-day count. We have 4 months left. That is 120 days. So R sub 120 means it's a 120-day rate or a 4-month rate. That rate's 1.6%, but the underlying has increased to 50.25. So the underlying price went up. And this is what a lot of futures traders, when they first begin, don't quite understand. When I entered the futures contract, the underlying was $50. It's now 50.25. I should be making a lot of money. And they find out that sometimes they're still losing money because they haven't overcome the change in interest rates and the passage of time. Let's see what happens here. Our underlying now is 50.25. This is ST minus the present value of the contract. Remember, the 50-50 is fixed. Nothing we can do about that. We're discounting it at a lower rate now. Remember, Lower rates are not good for us, and it's a shorter amount of time. Remember, a shorter amount of time is not good for us either, right? Because we have to overcome that time. We're up 2 cents. The underlying has moved 25 cents, but we're only up 2 cents. The underlying has added 25 cents to the value of our contract, but the passage of time and the lower interest rates have taken away 23 cents. So we're up 25, but this brought us down 23. We're only up 2 cents. And this could be confusing for futures traders when they first begin because they think the underlying is going up, but I'm not making any money. This can't be right. The calculation must be wrong. And it's not wrong. It's just that you have to get the spot price from this point all the way to this point just to break even, and it has to happen in this period of time. Well, if the underlying price doesn't move fast enough to overcome the interest rate in a given period of time, even though it is going up, you could still lose money. Okay, I'm going to walk you through a complex example. I've made this example up. The reading doesn't really go into the difference in interest rates over periods of time. It assumes one interest rate for all your cash flows. So that when you're pricing out a forward contract and you have income and you have costs, it assumes in getting to the present value of those income and costs, even though they happen at different points on the timeline, that you're discounting them back all at the same discount rate. In fixed income, we learned that yield curves, are typically upward sloping, which means a 30-day rate would be lower than a 60-day rate, which would be lower than a 90-day rate, etc., etc. So what we're going to do is we're going to calculate the forward price of a contract with specific rates per period of time. So this screen looks confusing, but I'll break it down nice and easy. Here's a nice timeline for us. We have an underlying that is at $60. And we are looking for a 9-month forward contract. On this underlying, we get to 60.57. This underlying is going to have two incomes. In 3 months, it'll pay 50 cents. 3 months later, it'll pay 50 cents as well. And that's it. It also has two costs. 1 month after it pays the income, on month 4, we have to pay 25 cents. And 1 month after the other income, at month 7, we have to pay 25 cents. How do we get to 60.57? Well, it is the underlying ST, or S naught in this case, minus the present value of all the income plus the present value of all the costs. Well, we're discounting the first income for 3 months. We should use a 3-month rate. We're discounting the second cash flow, the cost, for 4 months. We should use a 4-month rate. This here is 6 months. We should use a 6-month rate. And this is 7 months. We should use a 7-month rate. So let's subtract the first income. It's 50 cents, and this is for 3 months. 3 months using a 360 day count convention is 90 days. So we find an interest rate for 90 days is 2%. So we'll discount it at 1.02 and of course to the power of 0.25 because it's only for 3 months. Let's find our next income. It's over here. Where is it? 6 months. 360 day count convention. That's a 180 day rate. There's our 180 day rate, 2.2%. We'll discount that back by 1.022 to the power of 0.5 because it's for 6 months. That takes care of our income. Now let's do the present value of the costs. Remember, we add the costs, right? First one is over here. It's at 4 months. That's a 120-day rate. So there's the 120-day rate. It's 2.1%. And to the power of 4 over 12 because it's 4 months out of the 12. The next one happens over here at month 7. 7 times 30 is 210. We need a 210-day rate. There it is, 2.3. And we put it to the power of 7 over 12. And then, now that we've gotten all of our income back here, and we've gotten both of our costs back here, this here in the square brackets is the total amount of money at this point in time. We carry it all the way to the end. This is 9 months. We're going to need a 270-day rate. That's 2.4%. There we go. And for your calculator check, and I put all the values in here, we get 6057. Nice complex example with the term structure of interest rates built right into the question. The other examples that we've seen have assumed one rate, and we may get confused with that, thinking, oh, there's always one rate for all the cash flows. The author should have put a sentence in saying, assuming a flat term structure, this is how you would do it. And if we assume a flat term structure, that means every interest rate for every period is the same, because the term structure of interest rates is flat. This term structure of interest rates is upward sloping, which is normally what you would see. So let's get used to it now. You're going to see it at level 2. You may as well see it now. All right, let's value the contract. And let me just erase some of this stuff so that we have our screen take some of the stuff. We're going to value the contract right here. This is month 5. The underlying price is $61.60. So we know we're going to take $61.60, we're going to subtract any future income, we're going to add any future expenses, and then we'll compare that number with the present value meaning only to this point in time, of whatever the contract price was, which was $60.57. Well, we're at month 5, so the first income is 30 days away. The first expense is 60 days away because that's at month 7, we're at month 5, and there's only 4 months left in the contract, which is 120 days using a 30-360 day count convention. Let's begin. This is nice and easy. All we're going to do, we visualize this and we say we got to bring all these dollar amounts to the same point on the timeline. So this is already there, so it's $61.60. We're subtracting the income. We have 50 cents. Oh, sorry, I'm on this line here. We have 50 cents. We need a 30-day rate. Here's our new rates down here. You can't use the old rates because time has passed. At this point in time, we have to use new rates. So these are the new rates at time t. The 30-day rate is 1.6, so we'll discount it at 1.6, and it's to the power of 1 over 12 because it's for 1 month. Looking forward, there's no other income. We're done with the income. Look forward, month 7, we have a cost of 25 cents. Since it's a cost, we're adding it. From month 7 back to month 5 is 2 months. That's 60 days. We need a 60-day rate, 1.7. There it is, to the power of 2 over 12. Now we've collected all these terms. We're ready to subtract the forward price. This is 4 months away, which is 120 days. We need the 120-day rate, which is 2%, so we'll discount $60.57. Again, that's the contract price. That never changes, right? 1.02 to the power of 4 over 12 for 4 months. We get $1.18. That is a very complex example that has pricing of a forward contract with incomes and expenses, all with a differing term structure of interest rates. You will never get something more complex than this. Everything will be easier than this. So if you understand this complex example, you should be able to price out any forward contract because it will be easier. What you want to pay attention to is not so much the calculations, but the effect of certain things on the value of the contract. How does income affect the value of the contract? How do expenses affect the value of the contract? For example, let's say that we were at this point in time, and let's just say there was no income originally. The underlying is a stock, and there was no income originally. And we get to this point in time, and the company declares a dividend payable here. What would happen to the value of the forward contract that originally did not have a dividend that now has a dividend? Well, we can see what happens, right? We would be subtracting the value of whatever dividend it would be. So that means the value of the whatever value we calculated is going to be lower by whatever this term is, because if this didn't exist, this whole term would be 49, well, almost 50 cents higher. And if this would be 50 cents higher, that means this should have been 50 cents higher. So if you're long an underlying that suddenly has a cash flow announced between whatever time you're at and expiration, the value of your contract will drop. You will lose money on the value of the contract. Just to be aware how different things would affect the value of the contract that you're holding. That is a more important skill to develop. All right, let's move over to Forex. This can be confusing. So if it gets confusing, what I want you to do is imagine that one of the currencies are a baseball. And I want you to imagine that the base is a baseball. That's all. So when we look at the price, let's say SP over B equals 128. And let's say this is CAD over USD. How we read this is $1 US is $1.28 Canadian. And that can be confusing for people because you have two currencies in there. Well, instead of saying CAD over US, say CAD over baseball. Just watch how easy this becomes. CAD over baseball. Well, one baseball is $1.28 Canadian. Well, that's common, right? How much is a baseball? $1.28. Well, what happens if this goes up to 135? What would you say about the price of the baseball? You'd say the baseball just got more expensive. And if this went down to 120, what would you say about the price of the baseball? You'd say, well, the baseball just got cheaper, right? Once you're comfortable talking about the price of the baseball, take the price of the baseball out and put $1 US in. Same thing. So if the currencies confuse you, change the base to a baseball, and then write out a sentence about the price of the baseball. And when you say, well, that makes perfect sense, everywhere you see the word baseball, put in $1 US. It's the same thing. So let's talk about currencies. Currencies have two interest rates. So we have to pay attention to that. Here is the forward price, price over base. 4 times T is simply our spot price, price over base, e to the power of RP minus RB to the T. These must be continuously compounded rates. If they're not, you must first make them continuously compounded rates. I don't think that the readings for derivatives go to that detail. They just make the assumption that you're going to raise them to Euler's, raise them as a power to Euler's constant. So I don't think we have to ask the question, hang on a second, are these already in continuous compounded form? Value of the contract at time T is 0, as are all forward contracts. So at time 0, we can observe an exchange rate. We can observe what the T period interest rate is on the price currency, and we can observe what the T period interest rate is on the base currency. And rather than writing them out this way, we could just write them out as a spread. RP minus RB, the spread or the differential at time 0. And let's say we want to price out our forward contract at this point in time. And again, if this is confusing, just change the base to a baseball. What is the price? What is the value of a contract for the sale of a baseball at this point in time? At this point in time, we will be able to observe whatever the spot exchange rate is. We will also be able to observe what the interest rate is for this period of time in the price currency and for that period of time in the base currency. They may or may not be equal to the same price here. There's no reason they need to be equal. If they are, it just means the market hasn't decided that the rates would be any different for this short period of time versus the long period of time. And we have our interest rate differential at time T. For a long position, a widening interest rate differential will support gains. So if this differential begins to widen over time, remember the passage of time will take away gains. The widening of the differential will support gains, and a rising spot price, a rising exchange rate will support gains as well. But if the differential shrinks, that supports losses. So let's just do a little example here. Let's say that we're long this exchange rate, US over Euro, and we have a forward price of 1.2010. What we observe on day 0 is the US interest rate is 0.5%. The euro interest rate is negative 0.25%, and the current spot exchange rate is 1.192. So we know we get our forward rate by taking our spot rate multiplied by the ratio of the two interest rates. Another easier way to think about it is this. Take the price currency and multiply it or compound it by the price interest rate, and then discount it by the base interest rate. It's the same thing. This over here is the same as saying 1.192 multiplied by 1.005 to the t over 0.9975 to the t. It's the same thing as writing it out that way. Your forward contract will gain if the price currency interest rate rises, if the base currency interest rate falls, or if the spot exchange rate increases. All right, let's do two examples here, and I'll just extend this line like this so you can see that the screen is split in half. Let's just pay attention to the top of the screen. This is what we had on the previous screen, US Euro. We had 1.192 as a current spot. We observed a 1-year US interest rate of 0.5% and a 1-year Euro interest rate of negative 0.25%. Remember, we have, because these are interbank rates, we have a 30-360 day count convention. So a 1-year rate is, we just put in brackets 360. We denote it by the number of days. Let's raise the US rate, the 1-year rate, by 25 basis points immediately. We already calculated, I'll show you on the previous screen how we calculated our forward rate. Let's calculate the new value of the contract. And it is the current spot price, 1.192, minus the forward price discounted back to this day. But now the interest rates have changed, right? So we just discount this back at the new interest rates. And it is 0.0075 because it was 0.5%. Now it's 0.75% minus what the other rate is, but the other one's a negative, so that's why this turns to a plus. And we get 0.00295. Interpret that number. It can be confusing as to what that number means. If it is, let's think about a baseball. USD over baseball equals, let's say, 120. And let's say that USD over baseball now equals 122. So that there's a difference of 0.02 in there. Would you say that I have 0.02 more baseball? Or would you say that that the baseball costs 0.02 more USD? In other words, is this 0.02 baseball or is this 0.02 USD? Clearly it's 0.02 USD. You wouldn't say, oh, it looks like I'm going to get 0.02 more baseball for my $1.20. You would say it's going to cost me 0.02 more US for that one baseball, right? So whenever we come up with a valuation, whatever this is, it is in terms of the numerator. It is in terms of the price currency. So how do we interpret this? Well, we would have to know how many euros were involved in this contract. Remember, if we're going long an exchange rate, USD over euro, we're long and short the base. If we're long, that means at some point in the future, we want to take delivery of euros and we pay the price. That's why we're long. Much like here, if we're long a baseball, we're hoping that the price of the baseball goes up because we only pay $1.20. Hopefully that baseball will go to $1.30. That would be fantastic, but we only pay $1.20. We take delivery of the baseball and we pay the price. Once you're used to saying the word baseball, say the other currency. We take delivery of the euro and we pay the price. The price is in US dollars. So we need, in every forward contract with currencies, you need some amount of the base at which the contract is for. Let's assume it's for 50 million euros. And we have this gain over here. The value of the contract is positive, 0.00295. What does that mean? If you multiply that by the 50 million euros, you get 147,500 US dollars. Again, you would not say that you have 0.00295 more baseball, right? You would also not say you have 0.00295 more euro. If you agree that we do not have 0.00295 more baseball, then all you do is just change the word baseball to euro. You must agree that we don't have that many euros. We have that many more US dollars. Because this is a contract amount that is fixed. Only the value of it changes. The price of it changes. I say that because the reading doesn't quite interpret it correctly. And it interprets changes in the value of the contract as the ability to deliver less or deliver more of something under the terms of the contract. That is not true. If you have a contract, you cannot change the terms of the contract. So this is for 50 million euro. And the forward price is 1.2010, regardless of what happens to the value of the contract during the life or even at expiration. At expiration, I must take delivery of 50 million euro, and I must pay 50 million times 1.201 in US dollars. No matter what happens, I cannot say I get to deliver less of this or more of that. The example that we're going to use for the South African rand, if you go through that example, it then interprets the gain and the loss in terms of you get to pay more or you get to pay less under the terms of the contract, or you get to deliver less or deliver more. That is not true. You can't change the terms of the contract. So, let's go. Let's say we're short the 6-month South African rand euro contract at 17.2506. Interpret that. What does that mean? We're short, so what are we doing? We're short and long the base. If we're short the base, what are we doing in 6 months? We're going to deliver euro. We're going to deliver it because we're selling. We're short, so we're selling. If we're selling, we have to hand something over and get paid the price. We're going to get paid 17.2506 South African rand for each euro. We are short the euro. And this contract pays off if the euro price falls. And let's again assume that it's for 50 million euro because the contract amount is in terms of the base. If we're going to deliver euro, how much euro are we going to deliver? We observe a spot price on day 0, 16.909. The South African the South African 6-month interest rate, because it's for 6 months, 180 days, is 3.5%. For the euro area, it's negative 0.5%. So we end up with a forward price of 17.2506. And you can verify that by taking 16.909 multiplied by 1.035 to the power of 0.5, and then dividing that by 0.995, because that's 1 plus, this is a minus, 0.995 to the power of 0.5, and you'll get to 17.205. And at this point in time, we will deliver 50 million euro, and we will get paid in South African rand for delivering those euros. Let's value this contract at this point in time. 2 months have passed, so there are 4 months left. And we observe the spot exchange rate is now at 17.02. We need interest rates. We have to look for 4-month interest rates in each country. So we need 120-day spot rates in each country. South Africa, 3%. Notice it was 3.5, now it's 3. And in the euro, in negative 0.3% from negative 0.5. So this differential was 4%. This differential is 2.7%. We're short. So we know that valuation is going to be the forward price minus the price at expiration, because for short, we want this to drop. So it'll be this contract price minus, hopefully, the lower price. That'll give us a gain. Which means if we're valuing it at time t, we have to take this forward price and discount it back. So here it is being discounted back, minus whatever price we observe at time t. It's just the reverse of what we're doing when we're long. 17.2506, that's the contract price. That cannot change. That's a done deal. You can't mess around with that. Let's discount it back for these 4 months. it is going to be RP minus RB in the numerator. And we have a negative because we're discounting, right? What's RP? RP, we're told now, is 3%. RB, the base, we're told is 0.3%. It's negative, so we add it. And it's for 4 months, so there is our T, 4 to the 12 minus the 1702, which we can observe. We get 0.01488. Interpret that. What does that mean? It's a positive number, so we must be in gains. But are we in gains in euros or are we in gains in rand? Again, would you say you have 0.01488 more baseball? No, you wouldn't. Which means when we see that gain, we know we have more of the price currency. We never have more of the base. The base is fixed. The base is part of the contract. It's 50 million. You can't get more or less of it. It's fixed. Do we have more or less of the South African rand? If we closed our contract now, what currency would we walk away with in our pocket? You always walk away with a price currency. Think of the baseball again. I buy a baseball for $1.20. I sell a baseball for $1.25. Do I walk away with 0.05 baseball in my pocket? Or do I walk away with 0.05 of the price currency in my pocket? Clearly the price currency, right? There it is right there. Multiplied by 50 million and you will get 2,094,162 South African rand. Let's look at interest rate forward contracts. And the one we look at in this reading, since it's a forward contract, we're looking at the forward rate agreement. So we can observe in the market at any point in time the term structure of quoted rates. And here we're looking at market reference rates. If we're looking at a forward rate agreement, the rate that we agree on is a market reference rate. It is not a government spot rate. It is a market reference rate, which you will sometimes hear referred to as an interbank rate. And we will have certain spot rates on the MRR, and I've just shown six periods, whatever periods you want them to be. And of course, it goes on through time. Forward rates are quoted, you'll see a little f with two numbers. The first number is when, the second number is what. Or you'll see it as IFR. I means implied, an implied forward rate in the form of X, Y, X being a number, Y being a number. The first number is when. When does it begin? The second number is what length of time is it for? So if we see an IFR 2, 3, this is the implied forward rate in 2 periods. When? In 2 periods. For what? For 3 periods. So it would be in 2 periods, for 3 periods, it would be this period of time. So if we're way over here and I say, I want to make a deposit here, which lasts to here, what interest rate would I get? Now you may say, well, how would I know what a 3-year rate will be at this point in time? Wouldn't we have to wait until here before we realize what it is? Well, we've learned in fixed income that we can imply what that rate would be because it would be a no arbitrage rate. Because we can deposit something for 2 periods and then roll it over for 3 periods, or we can simply just deposit something for 5 periods. We should end up with the same amount of money. Because if we don't end up with the same amount of money, we could buy or sell the forward rate agreement to earn more. So how do we calculate what the forward rate is for there to be no arbitrage? Well, we deposit money at the 2-year rate, and of course it's compounded in the period of 2 because it's for 2 years, right? Every rate you come across is quoted annually. So if you see a 2-year rate of 5%, that's not 5% for the 2 years, it's 5% a year for 2 years. And then we have the implied forward rate. Well, that'll be for 3 years. And it should equal what the 5-year spot rate is, of course, compounded for 5 years. We will be able to observe this rate. We will be able to observe this rate. We have one unknown. One equation with one unknown. That's easy to solve, right? If you do some algebra, you'll end up with a calculation that looks like this. This is, by the way, this is called the forward rate model. There's also a forward price model, but this reading doesn't introduce it. We just use the forward rate model. And how it works is you take the longest period of time in the numerator, divide it by the shortest period of time, and then you put it to the power of whatever this term is, the inverse of the power. So since this is 3 years, this would be 1/3. We have to take the third root of it, and then we subtract 1 because we have the plus 1 here. So just so that you can see the steps, the first thing we're going to do is take this term and divide through by it to bring it into what you see here. And then we'll have this term over here to the power of 3. Well, if we take the third root of this, we get rid of the power of 3. We have to take the third root of that side. Then we have 1 plus IFR left. Well, subtract 1 from both sides, and you will have your implied forward rate. Okay, let's walk through an example of calculating an implied forward rate for a period of 2 months here. Here is a term structure of market reference rates, 30 days, 60 days, all the way to 180 days, and each of these dots represent one of these rates. So this here is Z30, meaning the rate for 30 days. There's the rate for 150 days, the rate for 180 days. And again, worth repeating, all rates are quoted annually. So when we see a rate for 1 month that is 1%, that is not 1% per month. That is an annual rate of 1%, but it will only compound for 1 month. So to figure out what 1 month is, we would take 0.01 and you multiply it by 30 over 360. It's the same as taking 0.01 and dividing by 12. It's the same thing. Remember, these market reference rates have a 30, 360 day count convention, right? It's the same as just dividing it by 12. That's all it is. So just keep in mind that whatever, even though it's a 30-day rate, a 60-day rate, a 90-day rate, it's quoted annually. And a 30-day rate quoted annually means you will get that interest rate compounded for just 1 month. That's all it means, okay? So let's say that we want the implied forward rate when? In 3 months, and for how long? For 2 months. So we want it in 3 months for 2 months. Well, that's the same as depositing something for 3 months and then rolling it over into a 2 month. We should get the same amount as if we had just invested for a 5 month. So here's our implied forward rate for 60 days because it's for 2 months. It's for 60 days. We divide it by 6. Why are we dividing by 6? Well, 60 days is 2 months, right? And 12 divided by 2 is 6. Remember, I did that up here, right? If this were 60 over 360, it would be the same as 0.1 divided by 6. What is our first term? Is the 3-month rate. We're going to deposit for 3 months, then roll it over into this implied forward for 2 months. So there's our 3-month rate, Z90. We divide that by 4. Why? 90 days is 3 months. 12 divided by 3 is 4. And this is the 5-month rate. It's 150 days, 30 days per month, 5 months, that's 150. We're dividing by 2.4. How do we get that? Well, it's 5 months, 12 divided by 5 is 2.4. And I'm giving you a term structure of rates here, 30, 60, 90, 120, and 150. Let's calculate what this is right here. This is what we want to get to, IFR 60. But we got to get rid of all of this other stuff, or at least get it all to one side. First thing we'll do is we'll take this and we'll divide through by that. So 1 plus Z150, well, what's our Z150? 0.1876. Actually, we'll do the algebra first. So there is this term over here divided by this term over here, and we are left with all of this. Well, the first thing we can do is get rid of the 1, so let's get rid of the 1. There we go. But we have this divided by 6. So if we multiply both sides by 6, we get rid of it. Remember, once we divide this by 6, we'll get just a 2-month interest rate. Not quoted annually, but just the 2 months. Since all rates are quoted annually, this will give us the 2-month rate, but we have to multiply it by 6 to put it back into an annual rate. Let's put actual numbers in there now. What is the 5-month rate? 1.876. So there's 1.876, but remember that's annual. We only want it for 5 months. We divide by 2.4. What is the 90-day rate? The 90-day rate is 1.568, so there it is right there, but we only want it for a quarter. We divide by 4, and we subtract the 1, and we multiply it by 6. There's our implied forward rate, 2.3289. Let's see if that actually works. We should be able to invest at the 3-month rate, then roll it over into the 60-day rate, and it should equal what we would get if we just put everything in the 5-month rate. So here is the 3-month rate. Remember, that's annual, so you have to divide by 4. And then we roll it over, so it will continue to compound at the implied forward rate the next 60 days, or the next 2 months. You divide that by 6, subtract 1, multiply that by 2.4, and you'll get 1.876. There is 1.876. Why are we multiplying it by 2.4? Because this is the return for 5 months. All rates are quoted annually. So how many times can we get a 5-month return in a year? We can get that 2.4 times. You get to 1.876. It should equal what the 5-month rate is. We would be indifferent between investing for 5 months or investing for 3 months and then rolling it over at this implied forward rate for the next 2 months. Okay, we know how to calculate those implied forward rates. Let's look at the forward rate agreement itself. The price of a forward rate agreement is the implied forward rate. There is confusion thinking that the underlying of the FRA is the interest rate. It is not. It is the price of the underlying. The underlying is a deposit. It's the rate for a deposit at a future period. So if we're long the FRA, remember, when you're long a contract, it means you take delivery of the underlying. So we would be taking delivery of a deposit, and if we're taking delivery of a deposit, that means we must pay the interest rate to the other side who's making the deposit. So it says right here, long an FRA will pay the fixed forward rate and receive the market reference rate for the period A to B. Well, why are we receiving the market reference rate? For a forward rate agreement, no money changes hands. The amount that we're betting on, or the notional amount of the contract, doesn't change hands. We're just making a contract for the interest rate on that amount of money over a period of time. So let's think about it from the short side. Let's say you're going to get money in 3 months and you want to make a 60-day deposit. Well, you know what the forward rate is today, but you don't know at that point in time in the future whether you'll still get the same rate or not. What you don't want is rates to drop because you'll get less money. So you enter into a forward rate agreement to lock in that rate of return. When it comes time, when you receive your money and it comes time to make the deposit, you don't actually make the deposit. You'll make the deposit at whatever the market reference rate is. You can go anywhere and make your deposit. The contract doesn't actually accept the deposit. It's just for the interest on that deposit. So you'll go and you'll get the market reference rate. If the market reference rate is higher, great. You end up with more money, but you would lose money on the forward rate agreement. You would lose the difference between the two rates, thereby locking in the FRA rate. Well, what if interest rates are lower in the market? Well, you're getting less money when you deposit your funds. You're getting less money interest, but the FRA pays off by the difference, thereby guaranteeing you the fixed rate on the contract. So here's how this works, and we're going to introduce some terminology that this reading doesn't introduce, but you're going to see at level 2, so you may as well see it now. We have some notional amount that the contract is based on. No money changes hands, but there has to be some, saying, listen, you owe me an interest rate on how much money, right? So there's some notional amount. The author of this reading calls it notional principal, NP. As you go through level 2 and level 3, you'll find the authors there like to use NA, notional amount. So I'm introducing notional amount because it'll be more common as you see it later on. If you prefer NP, same thing. Don't get confused between notional principal and notional amount. NP, NA, same thing. I just like NA. Maybe you like NP. You go ahead and use NP. At time t equals 0. We can agree to a forward rate for this period of time between period A and period B. So it'll start in A periods and it'll last for B minus A periods. It'll last for this period of time. We're going to agree on a rate for a deposit over this period of time. Because we can agree to the rate here, we call the rate advanced set. Now, we know what the rate is here. We know what the fixed rate is, and we'll be able to observe what the market reference rate is, which we'll call the floating rate. We call this the fixed rate. We call this the floating rate. We'll be able to observe that rate, which means on this day, we will know what the payoff on this day is because there's no mystery left. We don't have to wait till B to figure out what the prices are. We have all the prices. We have the fixed rate, we have the floating rate, and that is for this period of time. We can figure out what the payoff at B is. But since we know what the payoff at B is, we discount that payoff to this date and we settle up on the beginning of the deposit period, not the end. That is called advanced settled. So FRAs are advanced set, advanced settled. We know what the forward rate is when we enter the agreement. This is the end of the contract period over here, even though this is the end of the deposit period. This is the end of the contract period because we'll know the payoff here, we can discount it here, and we settle on A. On date A we settle, not on date B. And then everybody goes their separate ways. The person who wants to make the deposit goes to make the deposit somewhere else. If it costs more, well, they made the difference on the contract. If it costs less, well, they had to pay the difference on the contract, thereby always being at the fixed rate. So the long position will pay whatever notional amount it is multiplied by just the interest rate. Notice we're not multiplying by 1 plus IFR because there is no principal. It doesn't change hands. It's just some notional amount multiplied by the interest rate multiplied by period over 360. Now the reading likes to just use the word period, multiplied by period, and it assumes that period is days over 360. So wrapped up in the word period is the fraction days over 360. I prefer period just to refer to the days, so I say period over 360. You can use whatever notation you like. If you don't want to write period over 360, you say, okay, well, I know period is this whole thing. Go ahead and write the word period. I like the word period just to signify the days, because that is the period of time over 360. So they're going to pay the fixed rate, and they're going to receive the market reference rate over that period of time. Well, if they're paying the fixed rate and receiving the market reference rate, we can net it out. Notice that it is present value, right? We're taking present value as at time A, because we know what it's going to be, so we may as well just discount it to today. If I know I'm going to get $1 in a month, well, then I know how much it's worth today. I can figure out the value of it today. So let's net them out. Well, it's the PV of both things. Both have NA. And since we are receiving MRR and paying IFR, anything you pay, stick a negative sign in front. So if you're always confused as to, well, is it MRR minus IFR or is it IFR minus MRR, just say, well, what am I paying? I'm paying the IFR, so that's going out. Stick a negative sign in front of the IFR so you know the negative sign goes in front of IFR. Times period over 360, and that is how we calculate the settlement amount. Let's look at an example. Okay, I've just copied this exhibit right from the reading. It has everything we need in here. Here we are at t equals 0, and we calculate the implied forward rate at 2.24299 for this period of time. It is when A, and for what? B minus A. So it's in 3 months, for 3 months. There is the implied forward rate. We enter into a long position into that contract. Here is the bank that enters into that contract. Here's the financial intermediary. So the bank will pay the fixed rate times a notional amount, which is 100 million yen, times the period, which is 90 over 360. This is the period of time right here, up here, that we're paying interest on that. And the financial intermediary in exchange will say, okay, well, I will pay you whatever the market reference rate is at that point in time times the notional amount for the period. So money flows this way, money flows that way, and it's just netted out. Let's scroll ahead. Here we are. We're at time T. We look at the market. We say, aha, the current 3-month rate is 2.15%. So what do? Well, the bank here has a contract, so it has to pay the fixed rate 2.24299 times the 100 million times the period. It'll pay $560,747.50. Notice we use simple interest only. It's one period. It's only one period. There is no compounding. 560, 747.50, and the financial intermediary owes the market reference rate times the notional amount times the period. Notice the two differences here. This is fixed, this is floating, everything else is the same. Everything else is the same. So when we net it out, we could just take the difference between the floating and the fixed. What is this company paying? It is paying the fixed, so we would put a negative sign in front of here, and we could just do this. What's the floating rate? 2.15. What's the fixed rate? 2.24. Is that going to be a negative number? It is, which means we have a loss. So we could just take the difference between the two multiplied by the notional multiplied by this, and you would come up with this number directly. You don't have to do both calculations because this is common term, this is a common term. All we have to do is just take the difference between the two, and you stick the negative sign in front of what you're paying so that you don't get your positives and negatives mixed up in terms of are you winning or losing. 2.15 minus 2.24 clearly is going to be negative, so it's negative, whatever the negative amount we get, times the 100 million, times 90 over 360, you'll get 23,247. And you can verify that if you take 560, 747 minus 537, you will come up with this. This is at this point in time. But we settle FRAs over here. So what do we have to do? We have to come up with the present value. Since we're discounting it for this period of time, we need an interest rate for that period of time. That is the market reference rate. Notice we're using the market reference rate, not the implied forward rate. So we'll take our loss and we'll discount it by 2.15. Why are we dividing by 4? Because this rate is quoted annually. This is only for 3 months. 12 divided by 3 is 4, right? Divided by 4. And this is the settlement that we would have over here when the FRA ends. That's it.